In the last lecture, we have discussed about your bitwise operator, where we have basically worked upon one problem related to how we are going to store a negative number. So now you are at least you have an idea about that the negative numbers are basically being stored in the form of 2's complement. Okay, so other than that, I
Sir,
just yes.
sir, you didn't share the link you were
No, no,
saying
actually, I
about.
have shared all these links. If this is what I'm showing you over there is, if you are going to open this class, okay? So in the class, you will see that I have shared these two links. Just check in your class whether you are able to see these links as well as PPT I have shared in the class. Okay,
Okay,
because right now what I'm going to do, first of all, I will contact the course coordinator, not course coordinator, the coordinator, and then I will create a single cohort, okay, of the entire batch, and then on the based on that, what we will do, we will start uploading whatever the announcement as well as whatever the PPTs we have, okay. But right now, till that moment of time, what I'm going to do, I'm going to upload all these PPT and in your class. Just open the class and you will see that I have uploaded two links of my videos. Over there I have explained the same thing which I have explained to you, related to your negative numbers and how you are going to perform the your bitwise operation, which are your like for example whatever the bitwise, like bitwise complement operator, as well as left shift as well as right shift operator. Okay, so let's begin again with our concept. So till now, I think you already know that we are working on class. Inside class, we are creating a public static void main method, and then we are using data types, different types of data types, to which basically we are storing the values. So you know that now how our byte or all these data types are basically storing the how much space they are basically acquiring for in our memory, like 1 byte, 2 byte, 4 byte, 8 byte. So you already have an idea about that thing too. And also you have an idea about that out of these 1 byte or 2 byte or 4 byte or what 8 byte, whatever the size of that particular data type is, 1 bit is always means stored for your sign bit. Okay. So if it is a 8 bit number, so 1 bit is always the most MSB bit, your most significant bit will tell us about whether it is a positive number or one is referring your negative number. That is why now only remaining 7 bits you which is going to tell us about that what will be the data value you can store. So that is why here if you are going to see over there, so the range of your byte, that the value which you can store it over there is minus of 2 to the power 7 to your 2 to the power 7 minus 1. So why we are basically using minus 1? Because we don't want to count 0 two times. Okay, so that is why we have written 2 to the power 7 then minus 1. So this is the range. Similarly for short, you will get 2 to the power, you can say that 2 to the power 15. Got it? Similarly, over here you will have 2 to the power 31. So this is how basically you can calculate your entire this your range. So we have also gone through, like by default, if you will see that your numbers, integer numbers is of your integer data type. Similarly, your decimal values or fractional numbers are basically in the form of your double. Okay, so if you want to use it for your float, so you have to write f, or if you want to use it for your long, then you have to write L over there. Okay, because it is of your integer data type, as I told you. Similarly, for your character, you have ASCII value. So if somebody is going to ask you that what will be the total number of means range of your entire character data type, so always remember this character is not a signed digit. Okay, signed data type. It is an unsigned data type. So that is why the ranges will start from 0 and it will start your 2 to the power c. We have 2 bytes, so it will be 2 to the power 16. Okay, so from 0 to 2 to the power 16 is the basic size of your character data type, because here we don't basically taking any MSB bit for your positive and negative number. So in character data type, you don't have any signed bit. Okay, always remember this point is again very important for you. What I just want to tell you is related to your typecasting. So till now, I think in the labs, you have already solved many problems related to your typecasting too. So there are two types of typecasting. So first one is your implicit typecasting, and the second one is your explicit typecasting. Okay, so implicit typecasting is basically done by your compiler. Okay, always remember this implicit typecasting performed by your compiler, and explicit typecasting basically performed by a programmer. Okay, like you. So you generally perform this explicit typecasting, and implicit typecasting performed by compiler. So in a scenario, if I'm going to write if I'm going to write byte b is equals to 8, and if I'm going to write int a is equals to b. Okay, so you know that my in the RHS I am having byte data type, while in the LHS I am having int data type. So it is of your your 1 byte, and it consists of your 4 byte. So in that scenario, it is also known as your upcasting. So upcasting is generally done by our compiler. Okay, so you don't need to, even though you can write it, it will not throw any error, and it will perform the same operation. Even though if you don't want to write it, so don't need to write it. It will automatically typecast now your byte. So it will store that byte number in your integer data type. Okay, so automatically this operation will be performed. But in the vice versa case, if this is my int and this is my byte, okay, so in that scenario, if you are going to perform this operation, so it will give you an error. Why? Because you are storing integer data type value into your byte data type value. Okay, so you cannot store it. Okay, so that is why you always get like type conversion, lossy compression kind of thing, error you will get it. Okay, so in order to sort out this issue, what we generally do, we generally go for explicit typecasting, where we generally write the data type name, like I have written byte over there, and I can write it like byte b is equals to this. Okay, now what I'm doing, I'm basically converting my this byte, sorry, integer data type into your byte value, and then I'm basically assigning it. Okay, now, but one more thing which you should keep in your mind is that I think we have already discussed day before yesterday in our last lecture, that if we have a byte a is equals to 127, okay, and if I am going to perform a is equals to a plus 1, so you know that the answer which we are getting it is your minus 128. Okay, so the reason why we are getting the number minus 128, like I have given you a theoretical means, I have just given you a concept that it is a kind of a cycle which you are which it is following. Like after 127, it will go for minus 128. If I am going to increment by 2, you will get minus 127. 3, then it will be 126. But in reality, how we are getting it, I am going to tell you. So I just want that every one of you should have an idea about why we are getting this number. Okay, why we are getting it. So the reason why we are getting it over there is because you know that if I am going to write byte b is equals to your a, okay, and you know that int a is your what your integer data type. Suppose it is a 8 value, okay. So you know that in the case of your integer data type value, so in the RHS we have 0000 how many times. So suppose I'm not counting the exact number of zeros, but just assume it that we have 32 bits, okay. So like this is of your 8, 8, 8, and here you are getting again 8. Let's assume. Okay. So these are what your total 32 bits, which you are basically storing for this number. So if you are going to represent 8 over there, so let's assume this is how you are representing 8 over there. No need to go for like how many zeros I have entered. So let's assume all these are what your 8, 8, 8, 8, and 8. Okay. Now what you are doing it now in your byte b, always remember in the byte b, how many zeros you will have? You will have only 8 zeros. Okay, like 0, 1, 2, 3, 4, 5, 6, 7. Okay, because I am starting it from 0, so that is why I'm just going for 7. So that is why total number of the allocated memory for this byte b variable is what, your 8 bits. Okay, here you have 32 bits, here you have 8 bits. Even though you are performing typecasting, okay, even though you are performing typecasting, so in the case of, even though you cannot store 32 bit into your 8 bit, so it means that you are basically deleting some of the bits. Okay, it means our compiler is deleting some of the bits. So always remember that our compiler in Java, always our compiler will delete all the MSB bit. So it will delete this bit, all these bits like that. Okay. So I will get only the your LSB 8 LSB bits I will get. So whatever the LSB bit I will get it over there, I will directly allocate only those LSB bits, which will be what, your 0, 0, for example, 0, 0, 8 we are representing 8, 4, 2, 1. So this is how basically we are representing. And while other these data bits are going to be deleted, okay, automatically they are going to be deleted by our compiler. So this is how basically we are storing the value. Okay, but in the case of your 127, and after 127, if we are going for 128, then why we are getting the negative value, why we are getting minus 127, it is just because that we already have covered one topic. Okay, and the topic is related to the negative numbers, how we are storing negative numbers in your Java programming language in the form of your 2's complement. So you already know that in the case how we are going to find out whether it is a positive number or negative number, the MSB bit should be your 1. Okay, like your MSB bit should be your 1, like that. So in that scenario, what will happen whenever you are getting these such kind of numbers, okay, which is greater than like 128, then in that scenario your MSB bit will become what, your 1. Actually over there it is acting as a data value, but here because we are deleting all these bytes, so what will happen, because it will become like 110 something like that. Okay, so what will happen now, this is what my negative number. So you know that negative numbers are stored in the form of 2's complement. So I will take the 2's complement, and once I am going to calculate the 2's complement, so the output will, the value which I will get it over there is 100 and minus 127. So after this lecture, what all of you should do after this lecture, just go through it and just whatever the, just convert this 128 into your binary numbers. Okay, and then in the MSB part, you will see that you will get the 1 number over here. And then just start performing, take the 2's complement. And once you are going to take the 2's complement, so the answer which you will get over there is minus 127. So that is why we generally call it as, it is a kind of a cyclic kind of thing. Like if I am going to increment a number by 2 or 3, so similarly I am going to decrement in the negative way, like that. Okay, so you should, but at least you should have an idea that why we are getting this number. Yes, any question? Okay. So this concept is again very important, related that how we are performing. So even in the case of typecasting also, we have to lose some data, because you know that our byte can store only 1 byte of data, means 8 bits. But in LHS you have 32 bits. It means we have to delete 24 bits. So how, which 24 bit we have to delete? So in that scenario, they always, our compiler always delete these MSB bits. So 24 MSB bit, it will delete 8, 8, 8, you know, it will become 24. Okay, so it will delete these 24 bit, and rest 8 bit it will pick, and it will directly assign these bit into our, this your data variable. Okay, and if it is a negative number, then we have to find out the value, because the value are going to be find out using our 2's complement. Okay, like, so this is all about, so we have already discussed about variable name, all the things. Operators, we have already discussed about the operators too. One more important thing which I just want to tell you about, because you already know about what is A++. Okay, so if I'm going to ask you about byte b is equals to 4, okay, and if I'm performing B++ over there, so the output which you will get over there is 5. Okay, so now from this statement, what you can understand is that whenever you are performing, okay, whenever you are using this your increment operator, even you cannot say that B is equals to B+1. Okay, actually here B is not equal to B+1. Here B is equals to byte of, because automatically it is performing the typecasting. Okay, even this your downcasting it will perform using this operator. So you can see it over there. See, B equals to B+1. So you already know that whenever we are incrementing the value, it will convert it into our integer data type. Okay. So here you don't need to write byte over there. So see, things will become quite simple for you too. Okay. So if somebody is going to ask you like in after some time that B++ equals to this thing, so in logically you can see it, yeah, B is equals to B+1. Everything is same. But yes, in the case of your B++ over here, you are our compiler will perform. If you are using these expression, it will again perform automatic typecasting. While here in this case, we will get an error. So we have to write explicitly. We have to write this expression. Otherwise, we will get an error. Okay. So always keep this point in your mind that what is the difference between B++ and your B is equals to B+1. Okay, so logically everything is correct, but only thing is related to your typecasting. Here typecasting is automatic. Okay, we call it as implicit for this expression, but here you have to done this typecasting explicitly. You don't have any other option. Okay, like this. Similarly, we have gone through all these operators, so you know that what is a 5 mod 2. So it will tell us about and it will return us about the reminder. Okay, what is a reminder? We are getting it. So you know that 2 into 2 is 4. So how many? What is the reminder? So 1 is the reminder. Similarly, 2 mod 10 mod 2. If I'm going to ask you, so you will get 0 like that. Okay. So this is just a modulus operator. Then you have equal to, all these are your assignment operators which you already have an idea. Now in the case of your bitwise operator and your logical bitwise operator, again these two concept, this concept is again very important. Okay, what do you mean? See, this operator and this operator. So sometimes you will see that in some of the program you are using this, some of the program you are using this. Okay, so this operator is what your bitwise AND operator. This is a bitwise AND operator, and this operator is known as your logical AND operator. Logical AND operator. So the question is, what is the difference between these two operator means these two operator, whether their functionality is same or their functionality is different. Actually, their functionality, with respect to AND operator is same. So you know that true false will always give us what? False. Only in the case of true true you will get true. In the case of false false you will get false, and false true you will get what? You again false. So only in one scenario where you get the at least one true, then only you will get the true result. So that is the basic difference. So the functionality is same, but what is the exact difference between these two operators we will see using one example. So let's take one example. I have taken one variable int a is equals to 3, and I have taken a second variable int b is equals to 5. So inside public static void main, I am writing this thing. Okay. So int a is equals to 3, int b is equals to 5. Then after you know about if statement. So if in if statement, if I am going to print plus a, okay, is greater than your b, and right now for initially I'm using bitwise AND operator. Okay, and if I'm going to write plus b is greater than a, then print plus a. Otherwise print your plus b. Okay, now what I'm going to do after that, I'm going to print system.out.println. I'm just writing SOP over there, system.out.println, and I'm going to print the value of a and b. So I will check in both the cases, am I getting the same output or different? Okay, so using this example, you will understand the basic difference between your bitwise operator as well as logical AND operator. Okay, like that. So initially we are using your bitwise operator. So let's take your first scenario. So in the memory, you will see that A is equals to 3 and B is equals to 5. So in the memory, if you will see over there, so you will see that we have two values, A is equals to 3 and B is equals to 5. Now let's start with this statement. So once this statement will start, so you can see over there, it is a pre-increment. So before performing any operation, what it will do, it will increment its value. So initially the value of A is 3. Now it will become A is equals to 4. Okay, A is equals to 4. Now here it is 4 and here it is 5. So you already know that 4 is less than 5. 4 is not greater than 5. So this condition will become what your false. Always remember, this condition will become what your false. Similarly, we have plus B is greater than greater than A. So what is B right now? The value of B is what your 5. Okay. So it will check for this. So in the case of bitwise operator, it will check for all the condition, even if you are getting false, even in the first statement also too. Okay. So it will check for plus B over here. So in the case of plus B, initially the value of B is equals to 5. So it will increment its value and B of the value will become what your 6. Okay. So 6 is greater than 5. So yes, the condition is true. Okay, so the condition is true. So you know that false true is what? False true is false. So this condition will be executed when it is true, and this condition will be executed. This is else. Okay, this condition will be executed when it is false. Okay, so we are going to execute this statement. So in this statement, what is happening? We are pre-incrementing the value of B. So now the value of B will become what? Your 7. Okay, so now if I'm going to print the output, so the output which I will get here is what? Your 4 comma 7. Okay, 4 and 7. This is the output which I am getting if I am using logical bitwise your bitwise AND operator. Now let's take the second case. Now in the second case, what I am doing, I am using logical AND operator. Initially I am using bitwise operator. Now I am using this logical AND operator. Okay, so what is the difference between these two operators? We will see right now. So here A is equals to 3, B is equals to 5. So in the given question, we have already initialized this value like that. Now let's check again how our code will execute whenever we are going to use logical AND operator. So in the case of your logical AND operator, first of all, it will pre-increment its value. So you know that the value will become what? Your 3. Initially it is 3, so it will become 4. So 4, here you are getting 4 is greater than 5. So you know that this condition is what? Your false. Okay. Now the thing is, in the case of your logical operator, okay, logical operator, once you will get false statement in the case of logical AND operator, okay, once you will get false in any one of the statement, what it will do, it will directly terminate this condition. Okay, so we are not going to check this condition. So logically you can also understand, because in the case of your AND operator will become false, so always it will go for else statement. It will never go for your this if statement. Why? Because whenever you are getting at least one f, so what will happen? You will get else statement. Okay, so that is why here in this case what will happen, it will never execute this statement, and what it will do, it will directly call this statement. So what will happen? It will increment the value of B over there, and the value of B will become what over here? Initially it is 5, it will become 6. So in this case, the output which I am getting it over there is what? 4 and 6. So in the case of your logical operator, sorry, bitwise operator, it will check for all the cases, even though all the cases are showing you false, false, false result. Okay. But in the case of your logical AND operator, even if one of the condition becomes false, so it will directly terminate it. Okay. Now the question is, what is the advantage? So now you can directly see that what are the advantages which we are getting it. So let's assume if in a if statement we have 100 statements, okay, 100 statement which we are checking it, and in all the statement right now we are using logic, your bitwise AND operator, okay. So let's assume my first statement is false. My first statement is false, and one in order to execute one statement, let's assume it will take 1 second of time. Let's assume, okay. So now my first statement is false, even though it will check all the 100 statement and it will execute all those 100 statement, and it will take how much time? Your 100 second of your time, okay. And at the end it will basically executing the else statement, okay, and executing the same else statement, because this else statement is telling us about the false, if you are getting the false result. But in the case of your logical AND operator, see, in the first statement, if we are getting the false statement, so it will not check other 99 statement. Hence, the time it will take to execute is only 1 second of time. So you can see that here in this case, you are just taking only 1 second of time. Here you are taking your 100 second of time. So it is going to reduce your time complexity too. Okay. So always remember, whenever you are using your conditional statement, okay, always use logical AND operator. Always remember, okay. Otherwise, what will happen? You can see that here you are getting time complexity, very high time complexity. So that is why these operators, these logical operators like AND and OR are also called as your shorts, your circuit operator. Always remember, if somebody in future somebody is going to ask you what do you mean by short circuit operator, so these logical operators are also known as your short circuit operator.
सर
Yes.
सर मतलब उसी स्लाइड पे एक सर मतलब उसी स्लाइड पे जाना सर एक बार.
Yes.
सर अगर इसमें सर एंड ऑपरेटर की जगह और ऑपरेटर अगर लगाते और वो
हाँ
पहले में
या
फॉल्स दे देते तो फिर तो कोई फायदा ही नहीं ना इसका.
नहीं, अब मैं बता रहा हूं, अभी मैंने एंड का केस ले लिया है, ओके. नाउ वी विल गो फॉर और केस, ओके. नाउ लेट्स टेक फॉर द और केस. नाउ फर्स्ट, अब क्या होगा हमारा और केस में? नाउ लेट्स टेक फर्स्ट bitwise OR operator. So in the case of bitwise OR operator, again what will happen? Initially the value will be what, 3 and 5. So you know that it will increment the value, it will become 4. 4 is greater than 5, so condition is false, okay. Now it will check for this case. Now in this scenario it will again check for increment the value, the 5 will become 6. 6 is greater than your 4, the condition will become true. So you know that true false is what? True. So that is why it will execute this statement. So that is why the result which you will, and it will increment the value 4 to 5. So here you will, for OR case, for your OR condition, you will get the output as what, your 5,6. Now what difference? So like for this scenario, you will see that your logical OR operator will also act the same thing, okay. Same result you will get here in the case of your logical OR operator if you are using it. But again, when the logical OR operator will give you the different result. So in the case of your logical OR operator, you already know one concept is that if any one of the operand, okay, so suppose if you are having multiple statement, and suppose for the first statement you are getting result true, false, 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 and so on, okay. So what will happen? You always get the output as true, okay, whenever you are performing OR operator like that. So in logical operator, if you are using, okay, if you are using, sorry, bitwise operator, so once you will get, even if you will get the true, okay, true, any condition becomes true. So in that scenario, it will check all the test cases, all your what your conditions, okay. But in the case of your logical OR operator, if you are using logical OR operator, if any one of the condition will become true, then what it will do? It will directly terminate the case. What I just want to show you is that suppose let's assume we have one more situation, 3 is greater than 2, Okay, let's assume, I'm just giving you an example, 3 is greater than 2. So in the case of your, if you are using logical OR operator, okay, logical OR operator, if we are using it, so you know that this condition becomes false earlier. Okay, so we have already discussed about it. This condition is true, then again it will check for this condition too, and it will say, okay, this is true or false, like that. But in the case of your logical OR operator, what it will do, it will go for true. So it will search for true. Once it will get the search, so it will not execute this condition. Okay, it will not execute this statement, and directly it will go for to your true block, like that. Okay, so any doubt so far, or got your answer? Yes.
No doubt, sir.
Okay. So that is the basic difference between bitwise operator as well as your logical and or operator. Okay, always remember. So generally in most of the scenarios we use bitwise operator with your values. Okay, like I have told you, I have given you, if I am going to perform 4 and 5, so what will happen? I will get the output like 0 1 0 0. So bitwise operator, always whenever you are using your bitwise operator with values, okay, always remember with values. So it will first of all it will turn that particular number into your bits and then perform the operation. So here it will first your change the bits and then it will perform bitwise operator. So the output which you will get it, 1 0 is 0, 0 0 is 0, 1 1 is 1 and 0. So the output which you will get if you are going to perform 4 and 5, so the output will be what your 4 over here. Okay, so this is all about your bitwise operator. So that's why it's very important to understand this concept. Okay, now after that, so similarly you have logical NOT operator. So logical NOT operator, I have told you, like if you want to, if true you have, then it is generally used with your Boolean conditions. Okay, for conditions we generally true. So if it is true, then it will become what your false. So it is a kind of a logical NOT operator. So you already have an idea about gates, because in 12th class you have already studied gates. So similarly you have AND gate, OR gate, as well as your NOT gate, like that. Okay, now in the case of your assignment, so there are 3 ways we can assign a value. Okay, assignment operator. So you know that this is an assignment operator. Always remember the difference between single invert equal to and double equal to. This is a relational equal to operator. Okay, it will check for whether 2 conditions are true or false, like that. But here in this case, it will always assign the value, my RHS value into your LHS value. So there are 3 ways we can basically use this assignment operator. First one is your simple. Okay, second one is your chained, and third one is your compound. Okay, so there are 3 ways you can basically use our assignment operator. So nowadays in your labs, in most of the examples, you are using simple assignment, where what you are doing, you are just using int a is equals to 5, like that. Okay, so basically you are directly assigning this value. While in the case of your chained, which you haven't used, I think most all of you haven't used this chained assignment. First of all, what we generally do, we will use declare all these variables. Okay, then later on what we will do in a using chained, you can also assign the values like that too. Okay, so it is valid in Java programming language. So what will happen, first of all, we have just declared these variables a and b, c as your integer data type, and in a single line we can write it like a equals to b is equals to c equals to 5, like that. Okay, so this is how you can use chained your assignment operator. You can use it like that. So how it will execute, it will always execute R to L. So your assignment operator always executed from right hand side to your left hand side. So it means that first of all it will take the value c is equals to 5. So now c is holding 5 value. Now the value of c will be stored in your b value. So that's why you will get 5. Now the value of b will be stored, assigned basically in your data variable a. So that's why you will get the value a over here. Okay, but I can but in there are very few cases where you will use this chained assignment. but still you should have an idea. Otherwise, if in question or exam or in any competition, you will get these such kind of questions. So you will directly say, okay, we will get a compile time error. No, we will not get compile time error. So it is means this you can use chain. Yes, any question? Okay, chain type assignment in your basically using, you can also assign value using chain type. Okay, and the third one is your compound. So compound, I think you have used, some of you have used. Whenever we are going to write a is equals to this thing like that, a is equals to 5. So you know that what does it mean? You are incrementing the value of a is equals to a plus 5. So again, always remember there is a difference between a plus 5 and your a is equals to a plus 5. Both of them are not equal to each other. Why? Again, the same reason. So the reason, if my byte b is equals to 1, if I am going to sorry, byte a is equals to 1, so if I am going to perform first operation, so it will execute successfully. While if I am going to use it with my second case, so again it will give me an int to that conversion. So basically here, using this your compound statement also, whenever you are using plus this kind of operation, so here also it will implicitly, my compiler will implicitly typecast this integer into your byte data type. Okay, so this is again a functionality of your compound statement. So if you don't want to basically use it, and if you are performing some operation, so and you don't want that I should go for int, or you don't want to write any explicitly any typecasting, so what you do, you should go for directly that particular whatever the variable you are using it, like byte a plus a is equals to like 5, like that. Okay, so automatically it will typecast this your integer into your byte data type, so you don't need to worry about that. Okay, so always keep in mind. So this is how basically you can use this compound statement. So I think compound statement, it is basically reducing that your load, that you have to typecast something, because automatically it is performing that typecasting. Okay, so you can, if you are using it, so no need to write it down explicitly any typecast. Even though if you are writing it, so it is not going to create give you any error. Okay, but if they have provided us that functionality, then why we should write these such kind of lines, okay, like typecasting code related to that. So this is all about what we have learned related to that. And last one is our ternary operator. So as I told you, in the case of your ternary operator, like suppose if you have a question, int a equals to 5, b is equals to 4. Okay, so you have an idea about if and else. Okay, so similarly, it is a ternary operator used for your conditional operator. So in a single line, you can directly write it like, if we have int x is equals to a is greater than 5. If this condition is true, then it will execute this statement, else this condition. So if this is true, then it will always execute this statement. For false, it will always execute this statement, like that. Okay, and you can also use nested conditional operators too, because you already know that you can also use nested if, like inside if, you can also use one more if statement too. Similarly here also, in your conditional operator, you can also write it like that. I'm just giving you an example, like if this condition is true, then again it will call b is greater than 2, like that. And if this condition is true, it will print this, else this, like that. Okay, so this is how you can write it like that. Okay, like nested conditional operators are also being written in your Java programming language. Now we have also discussed, so see, this is again very important. Like I have told you, assignment operator is always executed. So how your compiler is executing the code? From right to left. Okay, always right to left. So this is left to right. So you know that how I have executed these Boolean expression. First left will be satisfied. If it is false, okay, so no need to check for right statement, like that. So you should have an idea about that, how our compiler is executing these such kind of things. All most of the thing you will see that are left to right. Okay, except these expressions, and except your conditions, as well as using, if you are using this conditional operator. and your this assignment operator. Okay, like that. Otherwise, all of them are your left to right. So you know that about the BODMAS rule too, like that. Okay. So now you have to tell me about the output, what output I will get if I'm going to execute this code. So now we have completed this concept. Okay. Now I have to explain bitwise operator too. I will explain, no need to worry. Even though I have shared 2 videos too. So those who are having any doubt, just let me know. First of all, just try to solve these questions. So what you can do, you can just directly post the answer, what answer we will get, and just we will check whether your answers are correct or incorrect like that. Okay. So questions related to your operators. Yeah. You can use chat box for giving the answer of this particular question. So you can see it over there. Here we have created a class, and this is a public static void main, and here we have used. So let's check. I'm getting the answers from you all. So the first answer I got from Utkarsh is 10, 12, 12, 11. So 10, 12, 12, 10. So 10, 12, 12.
Sir, we can't see the question.
Yes, sir.
Okay. Yeah, this is the question. Is it visible now?
Yes, sir.
Yeah. Just go through the question. Take your time so that I can understand whether all of you are able to understand the concept related to operators or not. If you are facing any difficulty, we can discuss about it. No need to worry. But just think about it. What answer you are getting? Because in your quiz, okay, or in your mid-sem, or as well as in your end semester, you might get these such kind of questions. Okay, it might be possible you might get some complex questions too. But if your concepts are clear, so I'm 100% sure that your answer will be always correct. Let's check. Now all of you are, I think 90 majority of you have given me the same answer, that is 10, 12, 12, 2. And the answer is again correct. Okay, because it's quite simple that initially you are just taking the value x is equals to 10, and then you are incrementing the value. Okay, like that. So how you are this? Yes, the question. So kindly mute yourself. If you have any doubt only, then just unmute yourself. Otherwise, no, please don't unmute it. Okay, otherwise it will create a noise and all these things. Okay, so you already know that this is how basically we are getting the output. Okay, so now in the next question, let's go through it. In the next question, if what will be the output you will get? Let's go through it. If you are having any issue related to any question, just ask me. You can ask me. You can unmute yourself and ask me a question. Yeah. Yeah. This is yes. Any question?
Yes, sir.
Yeah.
Am I audible, sir?
Yeah. You are audible. Yes, Nandini.
So for the last statement that minus minus x, I'm getting the output 9.
For minus minus x, you will get the output what 9? Why you will get the output 9?
I don't know, sir. It's saying 9 in my this terminal.
No, I don't think so. Let me check properly. Others can too check
Sir,
the
if you
same
write
question.
single sentence, then it will show 9. If you write all the sentence, it will show 10.
Yes, sir.
What you said?
So if you write only the last statement, it will show the 9 output. But if you write all the sentence, then it will show 10.
Yes.
The answer is correct.
Is it so? Okay,
Yes.
so
sir.
then let me check.
Sir,
So
she's
just
writing
again,
it once
Sir, she's
only.
writing only half the
Decrement
problem.
once from 10 to 9.
Sir, she is decrementing from 10 to 9. Yes.
Okay. So then just write it down all the statement. No? So you have to write all the statement for that. Got it? So in that scenario, you will get the same output, correct output. So main reason is not just how you are executing the code. Main thing is that you should have an idea why you are getting. See, let me go through and why you are getting this answer. I will explain you. See, initially in the memory, always remember whenever you are assigning something, you will get the value x is equals to 10 over here. Okay. Now what you are doing, you are not pre-incrementing, you are post-incrementing this value. So what will happen? First of all, it will execute this statement. Okay. So once it will execute the statement, so it will print the value x is equals to 10, because in the memory right now the value of x is what, 10. But after once this statement gets terminated, what will happen? It will increment the value of x is equals to x plus 1. Always remember. Okay. So that is why what will happen now, the value of x will become what, your 11. Okay. Now after that, in the second case, we are pre-incrementing the value. Okay, it means before executing this entire statement, we are pre-incrementing the value of x. So that is why you are going to update the value 11 to 12. Okay, 11 plus 1 is 12. So that is why now after that you are going to execute this statement. So that is why the value which you are getting it as what, your 12. Now after that, what you are doing, you are decrementing the value. Okay, but this is a post decrement. Okay, not pre. So it means first of all it will execute the value of x. So right now the value of x is what, 12. So that is why it will execute the value of x as 12. And then at last what it will do, it will decrement its value. Okay, so once it will decrement the value will become what, 11 over there. Okay, now the value is 11. Now we will start executing this statement. So once we will start execute this statement, so what will happen? We are pre-decrementing. Okay, means before executing this statement, before printing this statement, we first decrement the value of x. So now the value of x will become 0. Now we will print the value. So that's why we will get the output. So Nandini, you got your answer?
Yes, sir. Thank you.
Okay. So this is how basically if you are facing some issue, so just go through it. Okay, one by one, just check it out, that how our basically memory, how we are basically keeps on updating the memory. But always remember that post increment operator will first execute that particular entire line of code and then update the value of x. So that is why we call it as post increment. First perform the operation, then we will update the value of x. Okay. Now, so I have shown you the answer. So let's again just calculate. So you already know, I'm not going through because it will take some time in order to solve this question. So you have to follow BODMAS rule over there. So whenever you are having any brackets inside this thing, so first of all, it will execute your brackets. Okay. First of all, so right now we don't have any bracket over here. So as I told you, it will always execute L2R. Okay. In this case, whenever you are having expressions, so first of all, and it will always check for the priorities. You know that first of all, it will go for 100 and then it will divide the value. Okay. It will become 20. Then it will add. No, sorry. Then it will perform this multiplication operation over there. 4. And then it will divide the value with 2 like this. Then after it will perform your operations. Okay. Like this. So you will get the value 21 as the output of this particular problem. Now, can anyone tell me that what will be the output of this question? Even I will explain this question. Okay, no need to worry because
So 20 and 10.
okay, 20 and 10 I'm getting. What about others? Is there anyone basically who is getting different answer? Yes.
So 40 and 5.
40 and 5. This is what you are
40
saying.
and 5.
Okay. Okay. You like this? What about others?
So 20 and 10.
20 and 10. So we are getting basically two different answer, to means two types of answers we are getting it. Is there anyone who is getting some different answer? They can post.
Oh, 40 and 5.
Okay, so if you are getting the answer only based on either 20, 10, 45, no need to post. But if you are getting some different answer, then you can post. Okay. Okay. So let's check it out, the correct answer. So the correct answer is 40 and your 5. So let's check it out how we are getting it. So you should have an idea about that part too. So as I told you that it is of your data type is what your integer data type. So let's take it, don't take, because it is a positive number. So no need to write down entire 32 bits. So how we are going to represent a 10 in your binary number? So this is how basically 8 is your 81010. Okay, like this. So this is how you have, and in the MSB you have 0 over there. Okay, 0000. So this is what 8, this is 4, this is 2, this is 1, this is 16, this is 32. So right now if I want to present means represent a 10, so 8 plus 2 is what 10. So I will make those bits as what your high bits. Okay, so right now I am getting what your 1010 over there, and others are what your 00. Now what I'm doing, I'm performing your left shift operator over there. Okay, I'm shifting towards your left. Now whenever we are going to shift left, so how many position we are shifting it? We are position two places we are shifting. So what we will do, we will go for 1010 and we will add what, 2 more zeros. Okay, we will add 2 more zeros. See, because we are shifting 2 decimal places, so what we will do, we will go for two we will digit we will add over there 00, and we will shift the value. All the values are shifted towards 00. So now if you will see over there, it will become what, 8421. This will become 16. This will become what, 32. So now my high bits are what, your 32 and your 8. So you know that 32 plus 8 will become what, your 40. Okay. So always one more thing which you should keep in your mind is that whenever you are performing left shift, okay, so your value will always increase. Why it will increase? Because your number of ones will always keeps on going like in a higher position like that. Okay. Similarly, in the second case, 20. So you know that how 20 are basically represented. So 20 will be represented like your 16 and your 4. Okay. So I'm going to write 10100. So this is how basically I'm going to represent my, see, 16 plus 4 will become my 20. Now here I am performing my right shift, okay, by 2. So it means what I'm going to do, I'm basically decreasing my value. Okay, so I will get, so I'm going to truncate these two 0 bit, and now I'm going to move these two, the entire numbers over in the towards our right hand side. So what will happen? This 1 will come here, okay, 0, 1, and then 0, 0, 0, 0, because this is an entire positive number. So that is why 101. So you know that this will represent what, your 5. So that is why the output which you are getting it for this question is what, your 5. So 40 and 5, this is the, so for positive numbers, no need to worry. But for negative numbers, again, as I told you that you have to perform 2's complement. So we'll discuss about it, no need to worry. Any other doubt related to this question? Anyone? Okay. So let's go for your next question. Now tell me about this question. What will be the output of this question if I'm going to execute this code? So just try to execute this code. No need to write the code, similar code and compile it in your system, but it's better to execute by your own. Okay, so that because it will tell us whether you are able to understand that concept or not. If not, then we'll discuss about it. Okay. Yeah, just go through it. What will be the output? So I got one answer, and just unmute yourself. Mute yourself. Sorry. Whenever you are having any doubt, then only just unmute yourself. So false and false, false and false. Okay. So all of you are telling me that we will get false and false. Okay. So let's check the answer. So the answer is correct. All of you have given me the correct answer. It means now you are understanding all the concepts. So let's go through it. So here you have 10 over there. Here you have 5 over there, and here you have 20 over there. Okay. So first of all, it will check 10 is less than 5. Okay, so the condition is true or false. So the condition is what? False. So always remember, it will never check for this condition. It will never go for this condition. It will just go for this condition. Okay, so false and false it will directly return, because always logical, these operators always return Boolean values, either true or either false. So only these values it always returns. So that is why you will get false over there. Similarly, A is less than B. Similarly, here in the second case also, Why? But in this case, it will check both the cases. Okay, always remember, even though you are getting the same output, but if you will check, but suppose if here we are getting some 0.00001 microsecond, so it might be possible over there this line will take 0.0002 microsecond or millisecond, whatever the time it is taking in order to execute this code. Okay, so always recommend. So from this lecture, one thing which you came to know about is that always prefer this your logical operator, okay, or so short circuit operator. And you also know the difference between these two. In this scenario, it will check for both the cases. Even though if first case is false, it will always go for the second case. But here in this case, it will only check the first case. If it is false, no need to check for the second. Okay, like this. Now this is the next question. Here we have used the ternary operator. Okay, so just let me know what will be the answer of this question. So here in this case, you have 3 and you are 6. So 3 is less than 6. So you have to check the condition whether this condition is true or false. So you know that this condition is true. Okay. So that is why the output which you will get over there is what your 3. Why? Because see, I am again explaining this. 3 is less than 6. So if this condition is true, so that is for true, it will print first. This is your first condition. For false, it will print this condition. So that is why here a value. So a value will be assigned to. So it will basically return the values. Okay. So that is why it will return a over there, and the value of a is 3. So that is why the value of C will become 3. So that is why the output which you will get over there is what your 3. Now, similarly, I think you can solve this question too. This question is again quite simple. Okay, like you have a equals to 12, and if you are performing this a plus this, so what will happen here? You will get what, 16. Here again you are decrementing the value. So similarly, you will get 16, 13, 52, and 10. Okay. So you know that how to perform addition. So basically a plus 4, you can call it as like a equals to a plus 4. Okay. So here you are having integer data type. So even you don't require this typecasting too, because you are already getting an integer data type in LHS or RHS. So here for this scenario, you can call it as like a equals to a plus 5, and this, sorry, 4. Here it is 4, and this 4 is same. Both are same. Okay. Now this is the question. Now tell me about the what output we will get for this question. Here we are using all the your operators. Okay, like your equal to operator, not equal to operator, greater than, smaller than, greater than, smaller than, less than, or equal to. Before that, just tell me about one question. If I'm going to write down system.out.println, okay, and my question is 10 is less than 2 is less than 5. If I'm going to execute this line, okay, so what output I will get? Can anyone tell me? 10
So
is
false.
yes.
False.
So I will get false. What about others?
Will return true, sir.
So we'll get true for only for
False
this
true,
question.
false true, false true.
Okay. So let's go for this question. Why I have given you this question? Because this question is again important, because through this question you will understand the concept. Okay. So what I have written inside system.out.println 10 is less than 2 is less than 5. Okay. So you already know whenever we are using these operator, it will go L to R. Okay. So my compiler will go for L. It will take the value 10. It will take the value right operand, and it will perform the operation. Okay. So we are using an operator. So it will check whether it is a true or false. So you know that this condition will return me what your false. Okay. That is okay. Now after that, false is basically being compared with 5. So you cannot compare these two values with each other. Okay, so that is why you will get an error, compile time error, because incompatible types, because you cannot compare false with your 5. Okay, so always remember, Like you cannot compare two strings too. It's not like that you can write hello is less than equal to hello like that. If you have
Sir,
two strings like that, okay? So it will give you an answer. Yes?
so can't we say that the 2 is lies in between 10 and 5 for this condition?
No, 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 no. See, every time now, whenever you are executing a code, for readability, you can say, yeah, it is okay that 2 is in, you can infer, yeah, it is whether it is a true or whether it is a false. But actually, whenever you are executing a code, always try to remember that how your compiler will able to execute the code. Okay. So as I told you, it will always check for from L to R. It will never take 2 first. First of all, it will take 10. Okay. Even I can show you about the internal structure of this thing, like it always use stack for thing, these such kind of operators. It will take 10, it will take 2, and then it will take this operator. So for operator they use some separate your stack, and it will take directly pop up like this, and over there we are going to perform the operation among these two. Okay, so if this condition is true, so what it will do in the stack, it will return as what your false. Okay, it will return false over there. Now you have false, now you have 5, and now you have this statement again, less than statement. Now you cannot compare 5 with false. Okay, you cannot compare it. So that is why you will get a compiled error. Okay, so always remember this thing. Now for this question, I think all of you have solved this question. So for this question, you will get A is equals to B. So you know that they are not equal to. So always remember, this is not an assignment operator. This is your equal to operator, where you are basically checking whether LHS and RHS are having same values or not. If they are having same values, then it's okay. Otherwise, it will give you an error. Similarly, it is a not equal to operator. So you know that A is not equal to B. That's why it is returning us true, because we are already telling whether A and B are not equal to. So yes, they are not equal to. That is why you are getting true. Similarly, A is greater than B. You know that A is less than B, so it will return me false. Here you will get true because it is less than, greater than equal to again false, less than equal to it is false. So this is how basically you can represent all these kind of your operators. Okay. So this is all about which we have discussed. So right now, how much time we have?
Sir, it's already done.
We are out.
Okay, before that, I am also going to explain you one concept. Okay, because one student have asked me the concept, and I have already pointed out. So that's why I have made 2 slides for that particular concept. Okay, so in the I think 2's complement, I will tell you to go through those slides. Okay, sorry, those links which I have posted in your your class of MS Team. And still, if you are facing any difficulty, just let me know, because it is a very time consuming thing in order to explain you. But whenever, if you are facing any difficulty, I am here to help you out. Okay. So the question which is related to this thing. Okay. Whenever you are reading some values, why I'm explaining you, because in some of the problems you will see that your test cases are not checking. Okay, you are not able to means check your test cases, whatever the test cases. Some test cases are running, some test cases are not running. Why it is like that? Okay, so there are 2 concepts related to that, which I'm just explaining you. Within 5 minutes, I'm just going to wind up this class. So the first thing is related to this thing. Okay, related. So you already have an idea about what is a scanner. Scanner is a class through which what we are doing, we are basically taking the values. Okay, okay, during runtime. So one thing which I just want to tell you about, that using this system.in, what we are doing, we are using a buffer. Okay, buffer, you can assume it like it is a stream, or you can call it as a temporary memory. Okay, so whenever you are going to write int num is equals to sc.next int. So right now you know that whenever you are going to write next int, then what will happen? You always take what during runtime, you always take integer value. Okay, so that is why it will take 5 over there. Okay, but one more thing which is very important is that during runtime, you are not you are not inserting the values during your runtime. Automatically your CodeZinger will take all the test cases values. But in reality, whenever you are going to execute this code in your IDE, then what will happen during runtime? First initially I will write 5, and then I will press enter. Okay, then I will start writing this John. So these are the two things I am just writing it. But whenever I am going to execute this entire code now, so I will get only this output, and the output which I will get it over there is only 5. So now the question that comes into your mind is why John is not printing? Because according to our knowledge, here for the first statement, this int statement, we are taking value 5. For the second stream, we are taking the value for John. But during runtime, whenever we are going to execute it, we during output we are getting only 5. So the reason behind it, because still right now, if you are not getting any error, then it is okay. But in future, I am 100% sure that you will get a lot of error related to that. Okay. So the reason is, see, whenever you are inserting even integer value or character value, float value, or your double value ahead of your string value, if you are basically inserting it, then what will happen? It will take this value too. This will represent your new line. Okay, whenever you are pressing enter, so it will also hold this this instruction in our buffer.
Sir, दूसरी class है.
Okay. Then I'm going to end this session. Okay, no need to. Okay, so this is just an what concept which I just want to tell you. Okay, so no need to worry. So I will discuss about it